Dear students, today we are going to talk about three more forms of expressing the refractive index of second medium with respect to first, or whatever the case may be. So let us start. What is critical angle? Before we express a refractive index in terms of critical angle, we must know what is critical angle. Well, you see, we will better discuss it in details sometime later, but for the time being, let us say when a ray is incident on a rarer medium from a denser medium, we all know that the refracted ray moves away from the normal. Now if we think of a situation that as we keep increasing the angle of incidence, the angle of refraction must also keep increasing, and some situation may arrive when for any given angle of incidence we have corresponding angle of refraction equal to 90 degree. That means the refracted ray is making 90 degree with the normal drawn at the point of incidence, and that angle of incidence for which the corresponding angle of refraction is 90 degree is known as critical angle. Well, this is possible only when we are incidenting a light ray from denser medium on a rarer medium. Now, once we have understood what is critical angle is that angle of incidence for which the corresponding angle of refraction is 90 degree, and this happens only when ray is incident from a denser medium onto a rarer medium. So from that definition we can clearly say that refractive index of second medium, that is rarer medium, with respect to first medium, that is denser medium, is equal to sin C. This is angle sin I. So sin C divided by corresponding angle of is sin R is 90 degree. So by sin 90 degree. But sin 90 degree is 1. So we have equal to sin C by 1, and therefore if we want to write in terms of refractive index of denser medium with respect to rarer medium, we reciprocate this expression, and therefore we get refractive index of denser medium with respect to rarer medium is equal to sin 90, that is 1, and by sin C, that is sin C. So you got this relation in terms of critical angle denoted by C. So this angle is equal to C. Angle of incidence is equal to angle of C only when R is equal to 90 degree. Now we define refractive index in some another form as the ratio of real depth and apparent depth. You must have read it in class 10, but we again revise it. We have taken an object at point O lying inside water, and we select two rays emerging from the object, one along OB and normally incidented on the layer separating water and air. So the ray moves undeviated straight in its own path, and we take another ray emerging from the object along the direction OC. And since it is entering the rarer medium, so the light ray is deviated away from the normal along CD. That angle, the angle that CD makes with normal C and 1, we take it as I2, and the angle that incident ray OC makes with normal C and 2 is, we take it as I1. Now according to the basic definition from Snail's law, we can have refractive index of air with respect to water. This is second medium and this is first medium. So refractive index of second medium, that is air, with respect to water, that is first medium, is equal to sin I1 by sin I2. But from diagram, if you see that the angle N2CO, that is I1, is nothing but equal to angle AOC. Alternate angles are equal, and therefore sin I1 can be written as AC upon OC. So we have written sin I1 is equal to AC upon OC. Similarly, for I2, you see this is the angle made by refracted ray with the normal CN1. Now I2, this angle N1CD, which is equal to I2, is also equal to the angle AIC. How this has come? You see, we draw a separate line to understand the thing in a better way. We have this line IC, and this is the refracted ray, this is normal. Now whatever angle is between N1CD must be equal to vertically opposite angle ICN2. These are equal. If this is I2, this is also I2. And once we have learned that this angle ICN2 is I2, then certainly for this right angle triangle ACI, we have angle AIC equal to I2. So if we got the value of I2, which is equal to AIC, is nothing but equal to the angle N1CD, that is I2. So we can write sin I2 equal to sin I2, this is I2 angle, sin I2 is equal to AC upon IC. So we got this. Now AC in these two factors cancel out, and therefore we are left with IC upon OC. So we get, and when we reciprocate it, we get refractive index of water with respect to air. So for that we reciprocate it. This value, refractive index of air with water, must be reciprocated to have the refractive index of water with respect to air, and that refractive index of air with respect to water is nothing but IC by OC. So we write it like 1 by IC upon OC, and that on rearranging we get OC upon IC. But OC is, here you see this is OC. OC is nearly equal to AO. When point C lies very close to point A, angle I1 is very small, and hence I2 will be also small. So for small angles we can understand that at side OC is nearly equal to AO. So we write for OC we write AO, and for side IC it becomes nearly equal to AI. So we write OC upon IC equal to AO upon I, and AO is nothing but the real depth. Here we are having the object inside the water, so real depth divided by apparent depth. We have to remember that this expression is valid so long I is taken to be very small. Now we are talking about yet another law, which is Brewster's law. Now before we talk about Brewster's law, we will talk something about polarization. What is polarization of light? We shall be discussing about it extensively in the coming chapter, but for the time being we want to have some short idea about the polarization of light. We have learned that light is nothing but electromagnetic wave, and in this case the ordinary light, whatever light we receive from sun, and in general whatever light we receive, is having vibrations of electric and magnetic field in all possible directions, and they are called general light or unpolarized light. But when the light ray is having a vibration in one particular plane, restricted to one particular plane, then we call it plane polarized light. Means vibration is only taking place in given plane. So that is polarization. We shall be discussing in details in the coming chapter about the polarization once again. So now it has been found, actually it was discovered by Brewster, that whenever light ray is incident on any interface which is separating the two medium and the another medium, and the light is passing through the transmitted through the another medium, then for particular angle of incidence, for a given particular angle of incidence, the refracted ray and reflected ray both are at 90 degree to each other, and in this case the reflected ray and refracted ray both gets polarized. So polarization takes place, polarization of ordinary light takes place whenever a light ray is incident at a particular angle of incidence, and that particular angle of incidence is known as angle of polarization or polarizing angle. And then when we apply the Snail's law, what is a Snail's law? Refractive index of second medium. This is our second medium, and this is our first medium. When light ray is incident at angle of polarization, then the refracted ray and reflected ray both make 90 degree with each other, and as a consequence the angle of refraction becomes equal to 90 minus IP, because you see the angle over a straight line is 180 degree, out of which this part is 90 degree, so that is being subtracted from it, so we are left with 90 degree, and it means R plus IP is equal to 90 degree, therefore R plus IP is 90 degree, therefore R is equal to 90 minus IP. And once we got the value of R, we can write sin IP by sin R equal to sin IP by sin 90 minus IP, and that sin 90 minus IP is nothing but cos IP, and that means sin IP by cos IP is equal to tan IP. This is known as Brewster's law. And that's all for today. Thank you and have a nice day.